Yeah, into the top box.
Okay. Is it started? Sorry. Can you guys see that?
Yeah.
Okay, so for number 1, the first is asking which end of the mRNA molecule is the 5' end and which is the 3' end. So on the paper right here, the blue part, the 3' end is at the beginning and the 5' end is at the end. B is what is the sequence of the template DNA strand? So you just do the from the 5' to 3', but the DNA, so not the uracil. So it's the oh, I did it backwards. So it's the T C T A T C G G G A T G A T T T G G C A A G C A, and that just matches up with up here without the U's instead. And then C, what is the sequence of the coding DNA strand? And this one is just the opposite of, or it's the complementary strand to B. And then D, let me share my picture real fast. Okay, so for D, I just have my picture right here. Can you guys see that? I think it's showing up. Okay, so for D, I have my picture here. You can see that. And it just has the coding strand on top, which is the 5' to 3'. And then on the bottom strand is the 3' to 5', which is the template strand. And then I just wrote in most of the letters from our answers up here. And then at the bottom here is our mRNA coming in, and it's 5' down here and then 3'. Okay, for number 2, A, the TATA binding protein binds directly to the TATA box, while the sigma factor binds directly to the -10 and -35 sequences. The guanylyl transferase is the eukaryotic enzyme that links the 5 carbon to one of the nucleotide to the 5 carbon of the other nucleotide. For C, the nucleoside guanosine, C, the answer is group 1 introns use the nucleoside guanosine as a cofactor during catalysis, while group 2 uses adenine. D, it's CPSF is the endonuclease that assists in terminating transcription in eukaryotes. E, FIIB, which connects the TFIID to the RNA polymerase 2. And TFIIH, which acts to phosphorylate and activate the RNA polymerase. And then F, the spliceosome is composed of subunits called SNRNPs. And these spliceosome subunits are composed of 2 components, which are proteins and small nuclear RNAs.
Okay. So for 3, it says this question concerns the proteins involved in transcription and RNA modification. For A, it says indicate 2 proteins in either prokaryotes or eukaryotes that act as a helicase to separate 2 DNA strands during transcription. And so for this one, we got IIH and poly A polymerase. And then for B, 1 protein in prokaryotes that acts as a helicase RNA from during transcription without the protein. And then C, it says indicate 3 molecules in prokaryotes during RNA modification as ribozymes. This one we got small nuclear RNA, SNRNPs, group 1 and group 2. And then D, we had indicate 1 protein in prokaryotes that acts as a transcription factor, and we got the sigma factor. And then E, it says indicate in eukaryotes that synthesizes a long string of nucleotides, the template DNA strand for RNA polymerase, and that was poly A polymerase. And then that's just for all of our answers right there.
All right. For number 4, we're going to look at electron microscopy method, which deals with R loops and I loops and pre-RNA and mature RNA and the template. So I'm going to try to show you my drawings. For A, we're just showing the pre-mRNA and coding loop there. And R loop is formed when you have an RM and R or mRNA binding to the template strand of DNA, which causes the other strand of DNA unable to bind. So there's a loop out there. So the pre-mRNA is before any introns are removed out of the RNA. So it's just as long, and so we have 1 RNA loop. Now, the mature RNA has the introns removed. And in this problem, it says there's 4. So for B, we can see that 4 I loops, and then that would mean there's 5 R loops. Yeah. And then there's my I loops and there's my R loops. And then for problem C, we see that there was a malfunction in the things that take out introns in the first intron. So we just have 1 less I loop, and as a result, 1 less R loop. So there's my drawing in the RNA for that, and it's either that. So idea is 2 total I loops would be 2, and our total R loops would be 3. And you can see I just should be in contact.
For number 5, this just had to do with what proteins. All right, number 5. So this had to do with the proteins and nucleic acid sequences involved in transcription and RNA modification. So A is which of the above is found in the bacterium E. coli. So we put -35, NUS A, and then RUT. And then for B, which is found in yeast, we put -25, the GC box, the enhancer, silencer, TFIID, and then the SNRP, and then group 1 intron. And then which of the above is involved in transcription initiation? Put -25, -35, TFIID, the enhancer and silencer, and then the GC box. And then for D, which of the above is involved in the transcription termination? Put the RUT, the NUS A, and then the group 1 intron and the SNRPs as well. And then for E, it was -25, -35, the GC box, enhancers, silencers, and TFIID.